Hello. So it has been a while, and then when I talk to my students, that's the end, it's a bit ugly. When I talk to my student, we find out that we do not have a video on the standard normal distribution, or some people call it the Z distribution, or some of the people call it K score. Depends on which culture you're going through. Like we haven't have a video for those. So now we are going to make a video about this. When is the normal distribution happening? In the previous video, if you're not sure about the normal distribution, feel free to have a look at it. So when we have any probability, yeah, they got a black wing pencil here. I'm sorry, just have to say it. When we have a normal distribution, we usually have the mean and the standard D there. So the question, when the question given to you, it's like a no-brainer. You have 175 for the height and 5. You will be able to find any of the probability of x bigger than 180 or probability of x smaller than 120, something like this. All you need is your GDC. Let's show it. Oh, by the way, our calculator, the video we use for this question is the Casio CG50 now. In the previous video, you see an older version, a CG30, 20. Yeah, we got improved, updated. So this is what we have. Now, when do you need to use the normal distribution of the Z distribution and the K-score? That is when we're missing either, I say either, the mean or standard D. So, which means that if we're missing those, we need the standard score, which we will be using two formula. If X is any normal distribution with mean and standard deviation, which we might miss any one, and the Z score would be equals to the value minus mean over standard D. All right, this is the Z score. This is the value, mean, and they are interlinked. I should have get my color pencil here. All right, and therefore our Z will be equals to normal 0 to 1 square, which aka when we are missing the mean and the standard D, we will have to use mean equals to 0 and standard D equals to 1 to find out for that value, particularly where it lies, how many standard D are there. So instead of drawing the diagram, now you have the mean, and this is mean minus standard D and mean plus standard D. Officially, it's 34.13%. But since we might not know how far x is away from the mean, so we have to find out the portion of it. And this is what we call the Z score or K score. Depends on which book you are. Make sense? So if that is the case, we will have an example. The classic is you will have, we will need two things: mean, standard D, value, and probability. The almighty magnificent four. We miss out any of them, you'll be given some of them and find a third one. But if we are missing mean or the standard D, we will need to use this formula. I again highlight this one. This is very important there. So, and this is on a formula booklet, don't worry. So let's have an example with those. This time we do not have either one. So let's start with something pretty basic. Say for example, a normal distribution. Let's do x. X is a normally distributed with, we don't know mean or standard D. But we know that probability of x smaller than 40 is 0.2. Oh, no, the deviation, we need one of them because of the... All right, find the mean. Since we have that, we will have to use the calculator with those to find out what we could have. So this is what we have. We need the mean. So missing that, we need the formula. Z equals to 40, this is the value, minus mean we don't know, over 6 should be equals to 1. So the probability is here, and this is where we need to use our GDC. Casio, I choose you. Oh, so it goes here with as a normal screen. We need to go to statistics. Statistics. That's my previous number here. So I will use the distribution. We are doing normal distribution here, but this time it's the inverse because the probability provided. We will use inverse when the probability provided. First of all, make sure this is variable because if they are list on any list, your number is wrong because it will based on the data you enter it there. So variable, tail, which side we want. So assumingly, if we draw a diagram, whatever, mean is here somewhere 40. We want anything smaller than 30, so we want this side. Therefore, we are doing the left. Bigger than should be the right. So this is left here. And the area, which is our probability, is 0.2. Since we do not have the mean or standard D, we put the standard D is 1 and the mean is 0. Then this is your Z score, which is equals to, now it's not a question mark, it's equals to 0.8416212. I'll just write a few more digits. Usually the answer should be 3 significant figures. Then you will be able to find the mean by a normal linear equation. Oh yeah, the mean looks like A, so I could rub that off. Just to let you know, fun fact, this video is not sponsored by any calculator or pencil company, although I'm still waiting for them to sponsor me. Please, that's why we need you to help me to boost up the popular. Anyway, so we have the calculator. Oh, yeah, you can see that. Okay, so we just key in this one, 40, I got my probability, negative 0.8416212 times 6, and then I got 40 minus it. So now the mean should be 45.04972, whatever. Here's the problem, 3 significant figures. So 45.0. Even if it doesn't go onto it, we have to copy the 0, and this should be the mean. The same reason, same way we get to do those. All right. Should you want more extra thing? That's already 8 minutes. Should you want, sometimes they will give you 2 probability and find out the simultaneous equation. Yeah. Shall we do that? Yes, we could do that. Let's do this. So this time, we do not know the mean. So normal distributed, we do what X before, right? So let's do Y. Normally distributed with mean and standard D unknown. So now we will have something fun here. Let's see. We will have probability of Y bigger or equal to 35 equals to 0.32, and probability of Y smaller than 8 equals to 0.26. This means that this time they give you 2 equations and they don't even give you either the mean and standard D. But it's fine. We can solve that because we got the Z value with those. So we have to do 2 ways. This is probability of Y bigger than 335. Probability of Y smaller than 8 equals to 0.26. Because picture is the left and right because it's different side. So same thing, always use the value minus, they will give you a negative number, don't worry. And we have 8 minus mean over standard D. Now we have our Z score, so I'll calculate it on this side first. So 35, mean, statistics, normal distribution, inverse. So this side, bigger than 35, bigger is on the right side, so it's right. 0.232, standard D1 means 0. Make sure you got that. Oh, This side, this one is 0.46769, but whatever. So if I rearrange it, I will have a simultaneous equation, which is 0.494679 mean standard D plus mean. All good? Okay, the other side, we got that. We need to score as well. So this time, 8 is small. Y is smaller than 8. So it's the left tail, 0.26. Standard D1, mean is 0. So I will have negative 0.643345. So now I rearrange it again. So I will have 8 minus mean equals to negative 0.63345 standard D plus mean if I do that. So I write it nicely. Running out of space. So we will have, then we have 8 equals to negative 0.64334 goes standard D plus mean. So I have two values, two unknowns. I have used the calculator, so it's a calculator paper. We will use simultaneous equation. So manual, you go to equation, simultaneous equation F1, two equation. I just key in the number 8, x, y, and the value. So xy value, pretty straightforward. 0.46769. 1 for mean and equals to 35. And then I have negative 64334. Mean is 1. And then we have 8. The calculator will give you the answer. Something looks wrong, right? Oh, I forgot the 0 point. That's why. Oh, 0.464334. Yeah, we need to build up the sense like, something not right. Let me fix it. That's right. Okay, so we will have our standard D there. Negative 6.4334. Finally we get it right. So now we will have our first one is the standard D. Standard D equals to 24. Mean equals to 23. This is how we find that when we need to. So the tricky bit is, which I have to do it a few times, make sure you have the correct value in there, and it should be pretty okay. So this is the fun bit of the, not advanced, but a bit more tricky, annoying normal distribution bit. All right, thanks for tuning in. Like, share, subscribe. Thank you.